HBM would like to present our new measuring amplifier system, PMX. It was specially developed for use in industry and also in test bench applications. It is very configurable and allows for very fast sampling and measuring rates and can be operated with the most modern software and web browsers. The modular layout makes it possible to adjust devices especially for the measurement task at hand. Modular layout means that different measuring cards can be used to record sensors and signals, or they can also be configured for the input or output. The measuring amplifier can be mounted two different ways: on a routing rail, in control cabinets, or directly on the wall. We have mounts on the back of the device for mounting on routing rails. They can be used to adjust the height. This ensures optimum adjustment of the mounting height later in the control cabinet. To fasten the measuring amplifier securely and reliably onto the routing rail, the device can also be permanently mounted on the mounting rail with two Allen screws after assembly. The second available option is a mounting plate, which can be mounted on the back in one position or rotated 90 degrees. That makes it possible to mount the amplifier anywhere on the wall or in the field. The amplifier comes with different plug-in cards. The blue optional field bus card can be obtained as a Profinet or EtherCAT variant. We also have an analog measuring card for current and voltage signals, the PX401. The second card is based on a PX455 4-channel carrier frequency with a sampling rate of 19 kHz. As an analog and digital input-output card, we have the PX878. It provides 8 digital inputs, 8 digital outputs, and 5 analog voltage outputs. A very powerful high-performance computer core works in the device itself. This allows us to equip PMX with a total of 32 calculation channels that are available for math and controller functions, peak value detection, and other similar tasks. Various connector sockets are available on the top of the device. We have the Ethernet connection for operator terminals, a USB connection for additional backup and data storage functions, and an optional CAN connection where CAN sensors or CAN field modules can be connected later. If several PMX amplifiers need to be synchronized, this can be done with the RJ45 sockets. The carrier frequencies and timestamps of the individual measured values for all synchronized PMX devices are synchronized. The maximum number of devices is 20, and the distance between the individual devices is 30 meters. In the device itself, we have a CPU with very high computing power, also an FPGA for all computing functions and calculated channels, and a digital signal processor for quick conversion. The maximum resolution for measurement signals is 24 bits. This high resolution also makes it possible to measure in very small partial load areas to ensure the quality of a component. The measurement accuracy of the PMX measuring amplifier is better than 0.1%, with plans for higher accuracy options in the future. A wide range of sensors can be operated using the plug-in cards of the PMX amplifier. This includes sensors for force, displacement, and acceleration, just to name a few. An S2 force transducer is attached via connectors which are available either as a screw-on version or as plugs based on push-in technology. Strain transducers can also be connected, especially for press applications. Then the pressing force is monitored and evaluated in the bypass. Displacement transducers are available especially for mounting. They work as inductive half-bridges or LVDTs and can also be operated via the PX455. CAN connections can also be used for later expansion. They can be used to operate CAN sensors, for example moisture and temperature sensors, or separate CAN field modules. So PMX offers the option of extending the number of channels beyond the existing 16 measurement channels. A system with up to 50 channels can be implemented very easily. The PMX can be operated as a standalone measuring amplifier system or as part of a group in an automation system together with a controller. HBM has developed the module for EtherCAT or Profinet, especially for standard commercial controllers like Siemens or Beckhoff. Both modules are identified by the color blue. They are used on the left side of the amplifier. If this is not needed, a blank plate is mounted here. Both field bus systems are designed to work as fast and efficiently as possible. This allows us to achieve high transmission rates. For EtherCAT, this means frame rates of up to 10 kHz, and for Profinet IRT operation at up to 1 kHz. Now we come to commissioning the PMX amplifier system. The sensors are wired to the connectors in a 6-wire configuration for this purpose. The feedback bridges still need to be installed in the sensor lead. After mounting is complete, the sensors are plugged into the appropriate measuring card modules, and the device is supplied with power. The device now runs through initialization and checks itself. On the top bar, there is a system LED with the corresponding status. All input-output cards, as well as the measuring cards, have a channel status. The flashing function indicates initialization. After it is complete, all systems should be running in the green range. If the system LED has switched to green, that means all internal components are tested and running. When green is seen on the measuring cards for a connected sensor, that indicates the status is okay. The open channels are represented in orange, which means no sensor is connected. 4 analog outputs on the output cards are already pre-assigned to the first 4 measurement channels. The 5th one is not configured yet. Its status is a red LED. Malfunctions can be detected easily in later operation of the application by the system LEDs. A broken wire or disconnected sensor is indicated by a red LED. This status can also be forwarded to a controller via the digital outputs or the field bus. This ensures fast service and repair and short downtimes. After the sensor is connected, the device detects the sensor and goes back into measuring mode. The internal web server can be used for all operation and parameterization of the device. It can be connected with the device via the Ethernet socket and operated on standard commercial PCs and operator terminals. In the industrial design, these operator terminals can also be used to operate the device and measurement in touch mode on the factory or operator level. The PMX web browser has 3 different user levels, allowing for complete parameterization with access rights to the PMX for operators, installers, and administrators. The only requirement for problem-free operation is installing a modern web browser on the panel or PC. This includes Windows Internet Explorer version 9 or later, Mozilla Firefox, or Google Chrome. Now let's connect the PC to the PMX for further operation via web server or the HBM Catman software. As mentioned earlier, the connection is made via Ethernet. Nothing else is needed. To create a connection to PMX devices, either the device name or the set IP address of the devices must be entered in the browser line. After the connection is set up, the overview page of PMX devices appears. All the measurement channels, as well as all the internal calculation channels and the status of the digital inputs and outputs, limit values, and the field bus appear in an overview. The web server also has 3 different user levels: operator, installer, and administrator. Different languages and a favorites bar are also available. You can click the question mark button to access help for the currently selected page. Other setup menus can be reached by clicking on them, and this includes system settings such as the device name, system time, firmware update, amplifier settings, and parameterization of the calculation channels after they have been calculated. The Amplifier menu automatically shows the installed measurement channels, which can also be parameterized in this menu. The user can switch between selections with the bottom menu bar or other amplifier cards in the device. Unassigned slots are also displayed. All 32 limit values are represented on 2 pages. Inputs, functions, and also limit values can be entered numerically. The 16 digital outputs can also be parameterized on a single page that provides a clear general overview. Each individual digital output can be selected, and a source can be assigned to a function in the lower area. A disk icon in the lower status bar indicates that device data has been modified but not applied in the device yet. You can do this by clicking. The status bar can be accessed to show all actions that have been performed in the device. All set parameters of the optional fieldbus card can be displayed in the fieldbus mask. In addition to the web browser, HBM's own program Catman Easy can be used to save and configure the PMX. All measurement channels, as well as the calculated channels and digital inputs and outputs, are now represented in the overview mask. Measured values can be displayed live. Quality and measurement data can be recorded and analyzed by numerous Catman AP and Catman Easy tools. The PMX measuring amplifier system also includes numerous application possibilities. We have 16 real measurement channels, as well as 32 internally calculated channels. We can also add other field modules via the CAN connection and easily implement systems with more than 50 measurement channels. The sampling rate for all measurement channels is 19 kHz, which gives us an overall performance of more than 400,000 measured values per second for the complete measurement system. Other functions can be loaded at any time by a firmware update, and new display options can also be implemented in the web browser in this way. The PMX measuring amplifier system is designed especially for monitoring press and joining systems, end-of-the-line test benches, condition monitoring, and industrial test benches for product development. From a simple front end for measurement signals to the calculated internal channels and a soft PLC that can be added in the fully expanded stage, PMX can be used for optimum control, measuring, and automation in the 4 main application fields.